This is a vertical profile of the atmosphere and what it looks like. You have from the surface going up, you have the troposphere. The troposphere is where the weather takes place. It's where we are. Temperature decreases as you go up. Now there may be some instances where as you go up the temperature is going to increase. That's what they call a temperature inversions. But as a general rule and overall, the temperature drops as you go up in the atmosphere, and you know that because if you've ever gone up a mountain, you realize that it's a lot cooler at the top than it is at the bottom. So in the troposphere, the temperatures decrease as you go up, and again, that's where the weather takes place. So obviously, that's where we're going to focus a lot of our assignments on because, well, we're talking about the weather, and the weather's in the troposphere. As you go up, eventually you hit a boundary, and what that boundary is where temperatures are what they call isothermal, meaning that they remain the same, they're constant. And whenever that happens, that means you're changing over to the next layer, and they call those changeover, the difference between one layer and the next, they call them the pause layers. Well, the first one after the troposphere is the tropopause, characterized again by the isothermal temperatures. So on a STUVI diagram, when you look at it and you find temperatures in the upper parts of the diagram that have gone constant, then you know that's where the top of the troposphere is. And the top of the troposphere changes based off of the temperature. So the colder it is, the closer that's going to be towards the ground. The warmer the air is, the higher up that's going to be, because the cold air is more dense and it will hug the ground versus warm air, which is less dense and it wouldn't hug the ground in the same manner. So once you get out of the tropopause, you enter what's called the stratosphere. And in the stratosphere, temperatures do increase, and they increase quite rapidly. But they don't get any higher than roughly 32 degrees Fahrenheit. So, but by the time you get to the top of the troposphere, you're talking about temperatures that are roughly minus 70, and then you've increased up to 32, positive 32. So yes, that's a huge increase. And the increase is due to the ozone layer being located within the stratosphere. So the ozone layer is what protects us from ultraviolet light that comes in from the sun. Now, granted, there are some issues with some thinning and some holes in it towards the polar regions, but generally that's what the layer is supposed to do, is completely protect us from ultraviolet radiation, the type of radiation that causes skin cancer. And as you go up from there, from the stratosphere, you hit that next layer, and that's the stratopause, again characterized by that isothermal temperature. Then you move into the mesosphere, and temperatures drop in the mesosphere down to like minus 130 degrees Fahrenheit. The other thing that's interesting about this layer is there's some clouds that have been more and more studied in this region called noctilucent clouds, and they're made up of tiny crystals of water ice. And we know there shouldn't really be any clouds in this layer because everything's supposed to be contained down here in the tropopause. But we're discovering there's been clouds up here, and we can see them every now and then. Usually it's at the darker part of twilight. And they're just being more and more studied because where does the dust come from for these particles to form, for that water vapor to condense onto? And some thoughts are that it's from volcanic eruptions that have sprayed up enough to get those, because once they get up there, they're stuck for a while because there's no winds and there's no weather to move it around. They're just stuck there. And so that's some of the thoughts behind it. So those clouds are being more and more studied because it's very interesting to have stuff where it doesn't belong. It's very interesting. But other than that, the temperatures drop in that layer, and you get to the next portion of it, which is the mesopause, again the same as all the other ones, and then you get into what's called the thermosphere. The thermosphere is a layer where temperatures increase quite a bit, all the way up to 2,000 degrees Fahrenheit. When you know about anything about the shuttles, the space shuttles, or anything that comes in from space down to the surface, it has to go through this thermosphere and this 2,000 degree Fahrenheit area. And after that layer, you get into space, or parts what they call the exosphere. Now, let's apply this to looking at what the atmosphere looks like. Again, we're going back down and looking at the troposphere because that's where the weather takes place. I'm going to go back to the AMS website, and I'm going to scroll down, and you can only see a portion of this, but that's okay, it still kind of works. I don't have to readjust it. You scroll down to the upper air, you hit STUVIs for selected cities, and then you can pick whichever one you like. I picked FWD, which is Dallas, Texas. And I did some analyzing of it to show you. This is also the same one that's in your assignments for your example of how to do one of your assignments for this week. And you're looking at the one to the right is the temperature and the one to the left is the dew point. And they send a balloon up twice a day. In some cases they might do it an extra time, but generally it's twice a day. And it's either 6 a.m. and 6 p.m. or 7 a.m. and 7 p.m. depending on if you're in daylight savings. They send up twice a day. They send a balloon instrument, takes all those recordings. Eventually the balloon gets too high and it pops and you stop getting the data. This is a Stuvie diagram. It's a special way of looking at it. There'll be other stuff we can do with it later, but right now you're just looking at it as being the vertical profile of the troposphere. I marked where the top of the troposphere is. There is a layer starting right there where you can see it starts to become isothermal, where the temperatures are relatively constant, and that would be the top of the troposphere. And it's Dallas, Texas. It's a lot warmer, obviously. And that means that you're going to find the top of the troposphere higher up than you might find it any other time of the year. Now this is obviously a real depiction of the atmosphere at this time, but the standard atmosphere, what they use to get good data from, is what it would generally look like, give you ideas of what would happen with the temperature, because temperature generally drops 6.5 degrees Celsius as you go up per kilometer. Now again, that can be different in different areas depending on if there's moisture involved, if they are saturated. I mean, it can be different, but as a general rule, that's kind of how you look at how the temperature drops as you go up. And let's see, some of the things I marked on here would be where the surface temperature is. And depending on where you look, if your location is below sea level or above sea level, then you might see that it doesn't exactly start at 1,000 millibars, which 1,000 millibars is generally what they would call the surface for most places. And then you'll notice that I marked where 50% of the atmosphere's mass is, because from 500 millibars down to the surface, 50% of the entire atmosphere's mass is below this point, and the other 50% is above this point. And I mean, all the way up to, we're talking atmosphere, meaning all the way up through the thermosphere. And obviously, most of the mass, the concentration of it, is down where we are, which makes some sense. I also marked where the temperature of the 500 millibar level is, and that's just so you can learn how to read. Find the 500 millibar line, read down to find the actual temperature. It also does the winds as you go up. That can be some very helpful data when we get to some severe weather and looking at areas for forecasting for severe weather. So stuff we can come back and look at. A lot of these lines on here are things we can use if we were going to find the base of the clouds, find out some other kind of variables like lifted index, which is again stuff to help you for severe weather forecasting. So if you have any questions on looking at these, please let me know now, because these will pop up as we keep going on through the semester.